Hello everyone, welcome back to my YouTube channel Code with Deepa. So today is day 68 of solving daily problems on LeetCode. Now let us see what today's problem of the day is. So today's problem is to calculate the number of steps to reduce a number in binary representation to 1. Okay, so question says to count the number of steps required to convert a number which is in its binary representation to 1. Now question says that we are given with the binary representation of an integer in the form of a string. Now we have to written the steps to reduce it to 1. Like if the given string is 1, 1, 0, 1 or something like this. So I have to convert this string to 1 and I have to return the number of steps required to do so. And I have to follow two rules. See, if my current number is even, then I have to divide it by 2 and store that number. Second rule is if that is a odd number, then I have to add 1 to it to make it a even number, and I will follow my rule number 1 then. Now it is guaranteed that all the test cases will reach to 1, which means that we can reduce every given test case to 1. Now let us see the example to understand this more clearly. So the given example says that the given string is 1101 and its output is 6. Now let us see that how output 6 is produced. Okay, so we know that 1101 corresponds to 13. Now if I check 13 is an odd number, then I have to follow my rule number 2, which says to add 1 and obtain 14 as my answer. Okay, again in the next step 14 becomes an even number and now I have to divide it by 2. It will reduce to 7. 7 is again an odd number, so I will add 1 and I will get 8. Now 8 is even, so I will just reduce it to half. Okay, next time I get an even number only, so I will divide it by 2 and then I will get a even number and then I will again divide it by 2 and finally my answer will be reduced to 1. Okay, so now let us try to understand this. If I take the given example, which is that the given string is 1 1 0 1. Okay, so this represents 13 and I know 13 is an odd number. So in that case what I have to do is I have to convert this odd number to a even number. Now to convert any odd number to even number, we have to just add 1. So if I will add here 1 to its binary representation, then it will become what? We know that in binary we have 1 plus 1 0 with the carry 1. Okay, so this will be my new number formed. Okay, and this represents the binary representation of 14. Now in the next step what I have to do is I have to divide this number 14 by 2 in order to get its half value. So if I see that I will get an answer of 7 while dividing 14 by 2 and its binary representation is 1 1 1. Now I can see that what is the difference between the binary representation of 14 and 7? It is this, the last bit. The least significant bit is just removed from the string, I can say. So I will remove this to convert my even number to reduce it to half. Okay, so the next string becomes this. Now this is an odd number and I have to convert this again to an even number. So to convert this, what I will do, I will again add a term 1 to this. Okay, now it will become 1 plus 1 0 with the carry 1 plus 0 with the carry 1 0 with the carry 1 at last 1. Now you know that this is the binary representation of 8. Now to reduce 8, what we will do, we will divide it by 2 and we will get an answer of 4, and for that what we will do, we will just remove the last bit. Now my answer became 100. Okay, and again I will check that this number is an even number, so I can directly reduce this number to 2. I have reduced this number to 2 and its binary representation will be 10. Now again this number is an even number, so I will reduce this number to 1 and its binary representation finally becomes 1. Now let us see the number of steps required to convert it. Okay, so this is my first step. This is my first step, second step, third step, This was here my third step where we have divided with 8, third, fourth, fifth, and this is my sixth step. Okay, so here you can see that the output was 6, and now you know that how this output 6 is produced. Okay, so now to solve this problem, let us see what is happening inside this function only. So while I can see that when I have a odd number, then in that case what I have to do is I have to first convert it to an even number. Then I have to perform the second operation and divide it by 2. So for any number which is odd, I will what I will do that I will create a count variable. I will create a count variable which will keep the track of my count or the number of operations I want. So initially my count will be equals to 0, but whenever I will encounter an odd number, so I will increment it by 2. And if it's an even number, so we have seen that only one operation will be performed, which will be of division. So in that case what we will do, we will say plus equals to 1. Okay, so while solving this problem, we will not convert it one by one to other numbers. So what we will do, we will traverse this string, and to convert this odd number to even number, we will also keep a track of carry variable. Okay, so whenever I will encounter an odd number, I will make my carry equals to 1, which will allow me to change the string. Okay, so let us see the code here. So first here you can see that we have taken the length of string. The second, we have created two variables, as I told you, count and carry. Carry will allow you to keep track whether it's odd and even, and count will count the number of operations performed. Okay, so now we are traversing this string in reverse order. We will start from the least significant bit and move towards the most significant bit. Now initially it will take the value 1. Now what I will do, I will check the value at string si position, that will be 1. 1 minus 0 will become 1, and my carry is initially 0, so 1 modulo 2 will be equals to 1, which says that the given number is odd number, so it is correct, and I will perform two operations, and next time my carry will become 1. Okay, so again when I will check in the string, I will move to the next character, which will be 0. Now I know that 0 minus 0 will be 0, and my carry is now 1. So it will again become a odd number. As we have discussed here, after 13 we got 14, and after that we have got an even number, odd number again. So this will be my second step. Okay, and again my count will be incremented by 2. So now my count value becomes 4, and my carry is 1. Now I will move to the next bit. It is 1. 1 minus 0 will be 1, and my carry is 1. So 2 modulo 2 will be equals to 0. So this condition is false. Now I will move in else part, and my carry will become 5. Okay. When I will move to the last bit, what it will say, that it is I will reach the end position and it will traverse only to 1. Now what I will return my count plus the one left bit, the last operation which I have to perform. Their sum will be my answer, count plus carry. Okay, so now let us try to run this code. So as you can see, it is accepted. Now let's just submit this to test for other test cases also. So you can see that we have successfully solved today's problem of the day, and I hope this video solution was clear to you. If you have any doubts regarding this problem, please leave it in the comment section. Like this video, comment on it, subscribe to my channel, press the bell icon to get daily notification about the videos I'm posting here. Thanks for watching. I will see you in the next video.